Before we talk about how to calculate the average mass of an element, I thought maybe we should have like a quick review of atoms and isotopes in general. So 3 basic parts. You have the protons, neutrons, and electrons. The center of the atom is called the nucleus, and that's where all of the mass is. So protons and neutrons have what we call a mass of 1 atomic mass unit. They're so small they don't even weigh them in grams. They actually came up with a whole other unit for it. So essentially they weigh the same, which is the reason why on the periodic table carbon has a mass of 12, because as you can see in the picture there's 6 protons and 6 neutrons. Electrons are about 2,000 times smaller than a proton and a neutron, so we actually just round their mass to 0. The only thing electrons, well, not the only thing, it's important, but electrons don't play a role in mass. They play a role in charge and in bonding. So the electron cloud essentially weighs nothing. The connection to periodic table, remember the atomic number is the number of protons, the mass is the protons and neutrons added together. And if you're assuming that the atom is neutral, then you need to have an equal number of positives and negatives. So if you're looking at an element like chlorine, it's a little ambiguous what the mass is in this case if you wanted to round, because obviously you can't have 0.453 of a neutron. And this is where we're going to start talking about isotopes. There is more than one version of chlorine, but there are basic things that it has to have in order to be chlorine. So for example, chlorine has to have 17 protons, and if it's not charged, that means it has to have 17 electrons as well. But the mass is a variable. Okay, there are some chlorine atoms that have 18 neutrons, and they end up with a mass of 35, and there are some that have 19 neutrons, and they have a mass of 36. So the neutron number can change, and isotopes have, like, sometimes you'll have one isotope that's like 96% abundant, and you'll have, or you'll have what chlorine's got going on, where it's basically a 50-50 split. And the next video is going to be us figuring out, how do you know how abundant they are, and if you do know how abundant they are, how do you figure out what the mass is? So, just to clarify with isotopes, the symbol for an isotope is this XAZ symbol here, where X is the symbol, A is the mass, and Z is the atomic number. That's the correct way to write an isotope. So if we were going to write all of the isotopes of neon that are up there, okay, we've got 3 neons, and they're all, in order to be neon, they all have to have an atomic number of 10. And that's where the similarity is going to end. So the neon, the first one has 10 neutrons, which makes the mass a total of 20. The next one has an extra neutron, so it's 21. And the third one has a couple more extra, so it goes up to 22. And as you can see in the picture, neon 20 is the most abundant of those isotopes, which is why on the periodic table, the mass is closest to 20 and farther away from 22 and 21 because they're not as common. So if you're breaking down a isotope symbol, you need to remember that the lower number is the atomic number, so that means there's 24 protons. There's no charge on this atom, so that means we also have 24 electrons. And in order to find neutrons, you have to do mass minus protons. So 28. If you're given backwards information, so you get numbers and you're told to build the isotope, the symbol is the easy part, so copper is Cu. Copper is number 29, so that's always going to stay the same. There's no mention of charge in this description, so we're just going to assume it also has 29 electrons. And 34 is not the total mass. You have to take the neutrons and add them to the protons, so the mass would be 63. Okay, so one more breakdown. Atomic number, 43. There's no charge because it would be written here, so that means there's also 43 electrons. And 99 minus 43 will be the number of neutrons. So an ion is what an atom is, a charged atom. It can either be made by gaining or losing electrons. So it's kind of backwards thinking, if you remember from honors chemistry. If you gain an electron, you end up with negative charge because now you have more negatives than positives. If you lose an electron, you end up with a positive charge because you have more protons than electrons. So if we're looking at like this isotope of oxygen, it's not a common isotope because it says 16 on the periodic table, but this is a real atom of oxygen. If we're breaking it down, proton number would be 8, neutron number is 18 minus 8, so we have 10. Okay, if this was not charged, we would have 8 electrons, but a -2 charge means that this atom has gained 2 electrons. So we actually have 10 electrons. So it doesn't affect the mass, it just affects the charge. Aluminum makes a +3 charge, so protons, there'd be 13 of them. If it was not charged, there would be 13 electrons, but a positive charge means we've lost negativity, so we're down to 10. And then neutrons is 26 minus 13, so we have 13 neutrons. On the first day of school, we colored in the periodic table, and you guys, did all the labeling and everything. So potassium is an alkali metal. You wrote down that it should have a +1 charge. So if you're building the symbol knowing that that's what charge potassium makes, we're going to start with K. We know it's +1. It's number 19. And on the periodic table, the average mass is 39.1. So I'm just going to go ahead and assume that this is the most common isotope and round it to 39.